Welcome, welcome. Okay, just checking. Everyone is here for pre-calculus, yeah? Just I know some of this is like a little mayhem. I'm gonna go ahead and let you guys chat to each other while I reset our screens. All right, sharing screen. Here we go. My Wi-Fi was dropping out all day earlier, so just hang tight with me. Hopefully, fingers crossed, you'd love to see this. Can everyone see my screen? Give me a thumbs up. Yes, great. Great, okay. Today is National Secondhand Wardrobe Day, AKA National Thrift Store Day, which is awesome. Love a thrift store. I'm gonna go ahead and send you the attendance link here. It looks like we are very close to full capacity. It's not perfect attendance today, which is great. So go ahead and fill out that attendance form for me, please. Go ahead and take a second to fill that out. If something's going on with your cameras or computer's lagging or whatever, just let me know. Mostly so I know that you're here, not just like big chilling. Cool. So I wanted to talk about National Secondhand Wardrobe Day because I think that is a super interesting fact and also potentially fun fact if people would do it. But if everyone bought one used item a year instead of new, so like if you were gonna buy a shirt, a new t-shirt, and then instead you went and bought a used t-shirt, we actually could save 6 billion pounds of CO2 emissions, which is like the stuff that's bad for our earth, right? That's roughly the equivalent of removing 500,000 cars off of the road for an entire year, right? Which is crazy if you think about that. That's just if one person if everyone, instead of buying one new thing, we bought an old thing. And so I think that that's like a very important fact for us to think about. And it definitely encouraged me when I heard that to do more shopping at thrift stores, at secondhand stores. Not to mention, it's just cheaper. So that's good for your wallet too. So what is the best thing that you found at a thrift store? Like, what is the number one thing? That's what you're putting in the chat, right? That's what you are putting in the chat. What is the best thing you found at a thrift store? Hand-me-downs totally count. Yes. A Hello Kitty backpack. Yo, lots of Hello Kitty stuff. That's what my other classes were saying too. Love Hello Kitty. Domino game. Nice. Excellent. Cute jeans. Oh, I love it. A belt. Yeah, absolutely. For sure, for sure. Mostly jeans. I like to buy jackets there because jackets are like super bad. It's super hard to make a jacket and they often last for such a long time. But then, you know, sometimes you get tired of jackets. So then some people take them to the thrift store. Monopoly. Oh, the credit card one. For sure, for sure. Sweet. Okay, Scene. Thanks for chatting with me about thrift stores. We are gonna jump in today. Today, you're gonna need paper and pencil. You're gonna need notes for and assignment for, right? Notes for and assignment for. Is there anyone who has any questions or thoughts before we kick this off? Good to go. All right, let's do this. So if you could go ahead and open up Precalc Notes 4, I'll put it on the screen, but if you could open up Precalc Notes 4, that would be super duper helpful. Because we're gonna do right now a type and weight, right? So we're gonna do a type and weight. So what I would love for you to do is take a look at what is called interval notation. So you have probably seen inequalities written like this, and you might have graphed them or seen them graphed like this, right? So x is greater than or equal to -3, right? Absolutely graphed like that. Excuse me, so sorry for coughing in your ears. I'm gonna have and mute really fast so I can cough again. Okay, I think we're back. Okay, so we've seen it written in inequality notation most likely, and then we've probably seen it written as a number line graph. And then today might be the first time, or you might have seen it written like this in the past, is we might write it in interval notation, which looks like this. So what I would love for you to do is looking at the screen. I want you to looking at my screen or looking at your screen on Precalc Notes 4. I want you to think about this. You're going to answer in the chat. What do you notice or what do you wonder? So you're going to type and wait. Don't send it. I want everybody to do their own thinking. They're going to type it and wait. So you are not sending to the class. But what do you notice or what do you wonder? What do you notice or wonder, or what patterns are you seeing as you look at this section here? I'm going to let us type and wait for about 1 minute, and then we will all press enter together. Type and wait. What things do you notice? Or what does this make you wonder, particularly about interval notation? What things do you see? When you're ready, you can go ahead and press enter at this time. Awesome. I'm loving these answers. I noticed that it has open and closed circles. I noticed that there's no variable, x variable in the interval notation. So I wonder if it's easier or harder to find inequalities or than inequalities. I noticed the interval bars and parentheses are determined by the signs between x and the numbers in the inequality. I noticed that the interval notation is using both brackets and parentheses. Someone noticed that there was an infinity sign. Someone noticed wherever the arrow points determines whether the infinity sign is positive or negative, for sure. Someone wonders what the U means. Notice that there's a greater than, or notice that greater and equal to and greater than sign is similar to a bracket. Yeah, that's a great noticing. Okay. So I love these noticings, guys. These are really great. If you have a chance to read them, these are some awesome wonderings. So something that I wanted to pull out that I think you guys saw. So this x is less than 1 is graphed like this, right? With the open circle and then is headed to the less than sign, right? And now we see my screen froze. All right, we're back. So open circle. These are exactly, we could say this in a different way by writing the quantity from negative infinity to 1. So if this is negative infinity over here where that arrow is pointing, we're going from negative infinity all the way up to 1. And I saw that someone noticed that when it is an open circle, it is parentheses, right? And when it's a closed circle, like in this next one, we see a bracket next to that number, right? So something that I can be thinking of is closed circle equals bracket next to the number, and open circle is parentheses next to that number, right? Parentheses. If you are the note-taking kind, this might be something good to write in your notes, is that the closed circle is a bracket and the open circle is a parenthesis. For sure. So that's why we see, like on this next example here, we have closed circle from 0 to 5, right? So this would be from 0 to 5. And we put the brackets there because they're closed circles. So really, I think personally, interval notation is like a faster way to write the intervals from the interval that we see. So like from 0 to 5 here. So I can see that 0 to 5 is happening there. I noticed that some of you guys noticed that there was a U, and U means or. U means or. So in this case, I can see that I actually like see the word or when I'm writing it this way. So the inequality says x is less than -3 or x is greater than 0. So on my graph, I can see open circle, -3 less than, remember that's the negative infinity sign. And then x is greater than 0. So it's headed to the positive infinity sign there, right? So if I'm gonna write this in interval notation, I always start on the leftmost side, the smallest number. And in this case, the smallest number is negative infinity. And it goes up to -3. It's an open circle, so I'm gonna put a parenthesis there. And then I'm gonna mark that there's a break. And the break, I'm gonna mark by using the U. Marking by using the U. And then it's gonna pick up again at 0, which is an open circle, parenthesis. And it goes from 0 to infinity. So I'll put infinity like this. Okay. One thing to notice, I don't know if anyone noticed it, I apologize if I didn't see this. What do you notice is next to the infinity sign? What is always next to the infinity sign?
Negative?
A negative if they're talking about negative infinity, for sure. For sure, if they're talking about negative infinity. Yeah, there's always parentheses. So when like we said, if it was a closed circle, it was a bracket. And if it was an open circle, it's parentheses. Open circle means like right up to that number, but not quite that number. With infinity, we can never reach infinity, right? So like, if you think of the biggest number that you could possibly think of, like maybe a Google, right? You can always get a bigger number. So like a Google N1, a Google N2, a Google N3, right? So the meaning of infinity means that like no matter what number, whatever you think the biggest number is, we can always add one to it and add another number and add a number, another number. So we cannot reach infinity. So it can't be closed like a bracket. It has to be open. So parentheses always have a bracket. So if I was going to sum up what we have been thinking about here, I would say a closed circle looks like that, but is used in a bracket. I would say an open circle is a parenthesis. And next to infinity, which is this like sideways 8 thing, always has parentheses next to it, whether it's positive or negative. We can never get to negative infinity. We can never get to positive infinity. And so we always have the parentheses. Okay. One interesting thing to look at is this last one where it says, where the G part here. So this is a depiction of all of the numbers, right, from negative infinity all the way to positive infinity. They are all a part of this inequality, except for the number -3, right? We can see that hole at -3. And so the way that we write it with interval notation is we say, okay, we're going from negative infinity all the way to -3, right? We're going to get right there, and then we're going to stop. We don't want to include -3. And then we're going to pick it up again at -3 and go all the way to infinity, right? So that U there is signifying that hole. The U is signifying the hole. Are there any questions so far on this interval notation? You can come off mute or you can ask them in the chat. Okay. Okay, so today we're going to use interval notation to talk about domain and range. Okay, to talk about domain and range. Hopefully, you were able to write down these graphs in advance or make a copy of the document. So if you are going to type it out, that is totally okay. You can type it out on your document. If you're going to write it down, hopefully you're able to draw these graphs in advance. If not, it's okay. You can draw them quickly. So for domain and range, what do we know about domain and range? Do we know anything about domain and range? Have we heard those words before? Domain inputs are the x's of the graph, for sure. So these are our inputs, the domain, and this is the x's of the graph or of the table, the map, whatever we're using, right? So domain is our inputs. We're using, it's all of the x's. Sweet, thank you, Kayla. So then if domain and range are opposites of each other, what would the range be? The output and the y's of the graph. For sure. Thank you, Kayla. Sending merits to you. Cool. So when we think about domain, we're going to be thinking left to right. And when we think about range, we're going to be thinking about bottom to top. Domain and range tells us a little bit about like where the graph exists. So if I'm thinking about this first graph and I want to think about the domain, I'm going to start from the leftmost side. So the leftmost point is right here at -4, right? So I'm going to go ahead and put -4. It's an open circle, so I'm going to go ahead and use parentheses, right? So open circle at -4. And then my graph continues to go to the right, and then it goes down and to the right forever and ever and ever, right? So it's going down and to the right forever and ever and ever. So it's going to continue going out to positive infinity. So I'm going to go ahead and write here, positive infinity. And I know that infinity always goes with a parenthesis because I can never reach infinity. I can never like grab it. So my domain for this function is the x values between -4 and infinity. Okay. My range is from the bottom to the top on the y-axis, right? It's my y, right? It's the output. So it's the function from the bottom to the top. So if I start at the bottom of my graph, I can see that this is going down forever and ever. That's negative infinity. So I'm starting at negative infinity, which always has parentheses. And then my graph goes up, 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 up. It goes down, but then it comes back up, 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 up. And the highest point that it can get to, is 5. And again, we see that open circle. So it's going to be parentheses. Open circle, parentheses. Okay. So my domain from left to right, my range from bottom to top. So looking at this next one, I'm going to do exactly the same thing. So my domain, I can see if I start on the left side, this is going to negative infinity, right? It's going to the left forever and ever and ever. So negative infinity. And then I'm going to come here and I see that it stops and there's a break here. So I'm going to go ahead and note that break by putting a 1. It's an open circle, so go ahead and use parentheses. And then I'm noting that break. I'm going to put a U there. And then as I continue to the right, it includes all the numbers, numbers, forever and ever and ever and ever and ever. So I'm going to start again at 1 and continue to infinity. So my domain from the left to the right, it's really like I can see my graph is going to the left forever and ever, I can see my graph is going to the right forever and ever. And the reason why we write that 1 there, right? The reason why we write that 1 is because there's a break in the graph at 1, right? There's a break in the graph at 1. It does not include the number 1. So that's why we want to include this part here where it's like it goes up to 1 from the left side and then it stops and then it goes, starts at 1 again and continues going. Are there any questions so far? Okay, so then with my range, I would want to start at the bottom. I see this is going down forever, so negative infinity. And then it's as I'm going up, here, I can see there is a hole here. However, there is a point on the graph right here that will fill it. So I don't need to talk about the hole on this one. Right? So I don't need to talk about the hole on this one. So it's going to keep going up. I don't have to talk about this because they sort of like the point fills the hole, so it doesn't really count anymore. And then it keeps going up, and this is going up and out forever. So it just goes all the way up to infinity. And infinity always has the parentheses. I want you to go ahead and take a moment to write, try to do the domain and range for the third graph. Domain and range for the third graph. If you think you've got it, you can go ahead and try to privately chat it to me. If you're using infinity, just type INF. So if you type this, that will mean infinity on the computer. So if you think you know what the domain is for this next graph, go ahead and type it to me privately. You can press enter. So it looks like we may want to see another example since I'm not seeing any chats here. So my domain is all my x's. So these are going out forever and ever and ever. So I'm going to start with negative infinity. And then it comes in here. I get to an open circle, but it's filled by this hole here. So it's basically like a full circle. Right, so I don't have to do a U, and then this is it's filled, and then it goes out here to infinity. So I'm going to go out to infinity like that. Right, so Axel is totally correct. The correct answer, you could write it on how to write it on the computer is like this: negative infinity to positive infinity. So we don't need to talk about the wow, my thing dropped out. If I'm ever talking for a long time, y'all, and you don't see me writing anything, it probably means my Wi-Fi dropped. So just let me know and I can fix it. So what I was saying about this about the holes here is that this point kind of counts for that point and for this point. So we can say that the domain is all the numbers from negative infinity all the way to positive infinity. In some worlds, like on an AP test, you might actually see it written like this, like a double R. The double R means all real numbers. So anytime you have from negative infinity all the way to positive infinity, that's all the numbers in the whole world, right? Then that would be like called all real numbers. Okay. So the range, remember, is the bottom to the top. Go ahead and see if you can take a stab at the range. Take a stab at the range, privately chat it to me so you're not giving away the answer. From the bottom to the top. from the bottom, the lowest thing I can see is right here at -3. And I see that that is an open circle, right? An open circle. So I'm going to go ahead and put parentheses. The reason why it's not infinity is because this is pointed up and so is this. So there's nothing that's going to go lower than this -3 down here, right? -3. So from -3, and then it's going up, 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 up. This is going up forever. So it's going to count for like all of this. Everything's being taken up, 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 up. It's going up, I mean, forever and ever. And this is also going up forever and ever. So it's going to be going up to infinity. Like that. We can't get to infinity. So we would say that the range is from -3 to infinity. This is really complicated, guys. I totally want to own that this is super complicated. And it's especially made complicated by the fact that I can't like hand you a piece of paper and we can't use highlighters. So I want to own it, and we're going to keep doing some more examples. If you are feeling good, you can try to do these next 3 on your own and kind of like check the answers as you go. But we're going to jump in here. Are there any questions at this moment?
Why didn't you include like the other one, the other line?
Why didn't I include the top line?
Yeah.
Yeah, good question. So it's because the top line's already being included, right? Like if I was talking about the Y's here, I'm just basically saying that like all the numbers above here are counted for. Everything from -3 all the way up to positive infinity up there. So it's counting everything at the same time. Does that make sense?
Yeah.
Yeah, so like this bottom line is kind of like, so this bottom line is the lowest thing, and then this is like counting for all of it, like that. Yeah, that's a great question, Emma. Cool. Okay, let's think about this one here. So my range, right? My range, this goes out forever and ever, right? So from negative infinity. And then I'm going to come here, and there's an open circle here and an open circle there. So that means I'm going to have a break. So I'm going to use the U. And then it goes down, and then it comes back up, and then it's an open circle here. So it's going to have a stop. So I know I'm going to have 2 like parenthesis things. So it starts with negative infinity, which always has parentheses. And then it gets all the way up to an x value of -1. And then it's an open circle, so you use parentheses. It takes a little break right there. And then I have u. And then it picks up again at -1 and continues until the x value of 5. So it goes all the way up to 5. And 5 is an open circle. You go ahead and use parentheses. All right. For our range, I'm going to go ahead and try a different color here. So my lowest point, I'm going to sort of see. So this point, this side over here is going down forever and ever. So if you imagine, like if we could continue this line, it would keep going down, 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 down forever and ever and ever, right? And so it's actually going to, like, this is the highest point on the graph, but it's also going to count for everything below here, right? So I don't even need to think about these ones here because all of these are being accounted for by this down forever, right? So I'm going to be at negative infinity all the way up to wherever this goes up to the top, which is like, I don't know, 3.5 maybe, I'm going to estimate 3.5. And it's an open circle. I'm going to go ahead and use parentheses like that. Okay. All right. These are funky, for sure, for sure. Does anybody want to try this next one? Kind of wild. Maybe you want to try. It's not just me talking. I feel like I've been talking for like 35 minutes now. Okay, I'm going to do it. Here we go. All right, for my domain. My domain, if I'm thinking about this, going out this way forever. So that's negative infinity. And then it goes this way, and then it goes down here, and then there's this dotted line. Dotted line means it's an asymptote. We can't get there. So it has a break at -2, right? So from negative infinity all the way to -2. And then it picks up again at -2 up here. And then it goes all the way to here, and then there's an open circle. So there's a break right there at 2. And then it continues on forever and ever and ever to positive infinity. So when I'm writing this one, I'm going to say, okay, it's going from negative infinity to -2. It's pausing. Then it's going from -2 to +2. Pausing. And then it's going from +2 to infinity. So the way that I would write that in interval notation is negative infinity to -2. From -2 to +2. And from +2 to positive infinity. Like that. Okay, I'm going to try to think about this with a different color for the range. For the range, I'm starting down here at the bottom at negative infinity. And I'm going up, 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 up. I can't cross this line, and that line's at 1. So I'm going up to 1. So I'm going from negative infinity. I'm pausing at 1. And then now over here, I'm at 1. And then I get to this point, and I'm going to have to estimate there. It's maybe like 1.2. At 1.2, I have another break. Or 1.3, maybe, I can't tell for sure. And then I go all the way up, up, up to positive infinity. So I'm at negative infinity. I'm going up to 1, taking a break. I'm starting up again at 1. From 1 to like 1.2, where I see that circle, that hole. And then I'm starting again, and I'm going from that 1.2 to infinity. Like that. Whew, these are complicated. Muy complicado for my Spanish speaking friends. Okay. Okay, last one. Last one, we can do it. Power through. Okay, for our domain from the left side to the right side, right? From the left side to the right side. So going out forever, negative infinity. Going, 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 no holes. It's going to positive infinity. Woohoo! From negative infinity all the way to positive infinity. Easy peasy. That one is good. All right. And then for my range, it's going down forever, so negative infinity. And there's no holes, and it's going up forever, positive infinity. So we say negative infinity all the way to positive infinity. Woohoo! Okay. I was going to poll you using my fist of 5 poll, but my poll is being annoying because hashtag technology 2020. If you could privately chat me, if you like don't get this at all, throw a 0 in the private chat. If you're like so, throw a 3 in the private chat. If you're like, I get this, it's totally fine, I'm gonna do this, throw a 5. Somewhere between 0 to 5. You can do a 1 or 2 if you're feeling less. Thank you for privately chatting me. Thank you, thank you. I'm seeing some 3s, some 0s, some 4s, 2s, 3s, 4s, 4s, 1s, 2s, 3s, 4s, 3s, maybe 4, 2.5. Yes. Okay. Thank you. I want to recognize that this is really challenging and that you might need to see a bunch of them. The good news is that every pre-calculus student in the history of the world takes does this exact thing with domain and range. So there are many, many, many YouTube videos that can like help you, and you can continue to watch. And maybe like sometimes you just need to hear it from someone who's not me or not your like immediate teacher. So if you go to your pre-calculus Canvas course, I have at the bottom of the page, I have like I've attached some videos. One's from my SF Math, who's like a cool dude who he just like does some of this work as well. And then one is like just like a standard math video. So there are 2 additional resources on Canvas. If you think those might be helpful to check those out. Your assignment is going to be very similar to what you are seeing. I am scrolling and this thing is not. Okay, so what you're going to do is you're going to practice interval notation using the same thing that we were looking at here. That's part A. And then part B, you're going to try the domain and range for each of the following graphs. It is totally okay if you make some mistakes, that's totally fine. If you want to type them, you can. If you would prefer to write them, I left like a box here at the bottom if you want to like write them down on paper and then just put in your answers there. And then for part C, you're just going to graph the picture on Desmo and see what it looks like. I just want you to do like a little bit of practice with graphing on Desmo. And then at the end, if you put your favorite day of the week meme, I will send merits, even if I don't laugh. This is my favorite day of the week meme, which is Tuesday over yet? Which I'm happy to announce, your Tuesday's over, yay! It was very, very challenging to do this for today. I do want to let you know that I'm having like additional office hours because I know this is really challenging. So it's not just 3:50 today, but from actually 3:30 until 4 o'clock, I'll be doing additional office hours if you want to drop by to get some more done. Are there any questions about your assignment, about like what we need to do today? Anything that I can help you with before we sign off? I'm checking the chat. For part C, do we have to include a screenshot of the graph? No, you do not. You just need to do it. You can do the graphs on Desmos. I don't need to see them. Will I be posting this lesson on Canvas? I'd really like to go over it at your own pace. Absolutely. I will post this video as soon as it converts, and I'll post it on YouTube and I'll send it out just like normal. So those are my normal pieces. Is it helpful to have the PDF? Like, is this part helpful? I don't know if this part's helpful. I kind of did some like chicken scratch on these ones. Do we like having the PDF? Yes, we do. Great. I'll send the PDF as well with the video. Cool. Yes, for sure, for sure. I will do that. Awesome. Okay, guys, I'm gonna let you go 3 minutes early because today was tough. If you are good to go, you can peace out. If you want to ask a question or stick around, I will stay for a few minutes afterwards. Thank you, guys. I'll see you soon. Adios. Bye. Bye, bye, guys.
Bye.
Bye. Hi, Mia's mom.
Oh.
Sister? Twin? Sister.
Sister.
Ah, nice to meet you.
I already met you before.
You met me before. When did we meet?
Senior year.
Senior year?
I didn't have your class. I was always just hanging out with Zion.
Oh, with Zion. Yeah. Oh my goodness. Blast from the past. Yeah. How are you doing?
Good.
Good. Hanging out. Are you in school right now or are you doing something else?
Doing something else.
Nice. What are you doing?
Just work for now.
Just work. Where do you work?
At the LAC USC hospital.
Oh, cool. That sounds cool. Do you like it?
Yeah.
More or less. It's work.
Yeah, it's fun.
Yeah, it's fun for sure. For sure. That sounds awesome. Oh, thanks for coming to say hey. All right, team.
Bye.
Bye. I'll see you guys later.
Bye.